Hey, welcome back to another Just 5 Mins. It's the down the rabbit hole a little bit too far on a Saturday morning version. Uh, so I did a little episode back in, I don't know, September last year, I think, episode 57 or something, about vectors, what they were and, all that sort of stuff. Because you keep hearing certainly in the AI world, vector databases and all that sort of stuff. So I wanted to dig a little bit deeper, and I sort of really did fall down that rabbit hole and realised I think I need to go back to school for some mathematics, sort of advanced mathematics sort of stuff. I might even try that, whatever it is, that website Brilliant or something, to try to get my knowledge back up to speed. So anyway, the reason being vector databases. Okay, so what is a vector? Well, essentially it's just an array of numbers. Okay, but it's not just, oh, I'll just put these numbers into an array, shall I? They're calculated. So a lot of these AI models, when they're training on data, they're looking at letters, words, phrases, sentences, paragraphs, but also images, audio. Essentially, a vector can represent complex data. Okay, but when it also calculates these vectors, it also well, okay, what do you do with that data? Then you've got things like these algorithms like KNN, which is essentially it's an algorithm which I didn't realise that algorithm was somewhere back in 1957. It was first brought out. So it's like the nearest neighbour algorithm. Okay, there's lots of others that are going on, but this was one other thing that I then went off on a tangent. Okay, I'll have to look at the KNN algorithm, and there's examples how you can implement this and all sorts of things, but that led me on to I found a really good website, actually. I'll put the link below. It's Math and Science, basically, it's called. But really a good example, because obviously trying to then understand the KNN algorithm, you're starting to get into sines and cosines and goodness knows what. So, yeah, time to go back to school, I think. But anyway, so a vector is calculated, if you like. That's the AI model getting trained on all this data, image, text, audio, whatever it is, and it represents this information as vectors, arrays of numbers. But the clever bit then is it needs to essentially cluster like or similar groups of data together, or at least have and that's where the KNN algorithm comes in, is that you can find the distance, the weighting between these sort of like clusters of data. And that's where vector databases sort of jump in, because they make that blazingly fast, because you've got things like relational databases, of course. Okay, but you've got rows, columns, indexes and all that sort of stuff. But again, vector databases are grouping these vectors in similar chunks, basically, so that when you want to go and find out, is a cat an animal, or is a cat like a dog, or whatever the query is, it's going to find that information extremely quick. And then you think, well, what is the point of a vector database anyway? Like, where does it fit? Well, the whole idea is, with large language models or even small language models, you've got this RAG pattern, this retrieval augmented generation. So instead of just taking the data that the LLM's been trained on, you can introduce your data, but also with a vector database, you can store that. So you can essentially give the AI memory. Okay, now I know ChatGPT and Copilot sort of does this anyway, but you can actually use these vector databases to store your own, well, that's why they say augmented generation, because it can actually look at your data as well as the LLM, for example, or not, or it might just be looking at something very specific. And that's where the small language models are starting to make inroads, things like the Phi 3 models and things, which I'll probably do an episode on, no doubt. when I understand it a little bit more. But anyway, but the point being is that there are actually vector databases out there. You know, there's Pinecone, there's one called Weaviate. Basically these vector technology, vector database technologies are finding their way into like Postgres, SQL, Microsoft SQL, that is. So, you know, you've got things like, you know, you've got vector enabled data in Microsoft SQL. Like vector tables and such in there. And then Cosmos DB, I think I touched on briefly, they've got something called disk ANN, okay, which is a vector indexing and search, which apparently I heard this on a podcast from one of the leads in Azure Cosmos DB, that it was actually ChatGPT used the Cosmos disk ANN vector indexing behind the scenes of ChatGPT to actually store a lot of the stuff that's going on. So I don't know that 100%. I'm going to do my research on that. But things like that, you know, you've got like flat vector indexing, quantized vectors. Goodness me, there's all sorts of things. It's obviously you've got to be a bit specialist in this stuff, haven't you? Otherwise, like me, you just end up, you know, melting your brain for something. But I can see the way that we're probably, like most people are going to end up using this is like the RAG pattern, like fine tuning, you know, AI models that are out there with your data, pulling that in, and of course you need somewhere to store your extra bits that you can tune your data on. So, you know, there's some really quite interesting stuff going on. There's lots of links if you really want to go down the rabbit hole. But this is meant to be a summary. I've already gone way over the just 5 minutes, of course. But as I say, I think where it's started to really become interesting is where it's starting to merge into your, like I say, your everyday databases like Postgres and lots of others, Microsoft SQL, of course. And the idea is that if you've got data in those databases, that you can start to maybe use that vectorization to say, okay, well, I've got a lot of data in here about this, that, and the other financial details or whatever it might be. You can maybe start to use those vector database features to actually find like-minded, like similar data. Ultimately, this has been around for a long time, of course, though, because that's why a lot of this, you know, marketing and recommendation engines sort of work underneath. I guess just the everyday Joes and Joettes basically just getting into this, and like I say, I think I probably do need to go back to school really and learn a little bit more about this, because there is obviously a fundamental mathematical thing here. But anyway, fascinating stuff, isn't it? That's what I've got for this time. I'll put some links below. Coffee powered as always. But take care until the next time, and we'll catch you on the next one.